Hello everyone, welcome to my Your Programming Club. Today we will be solving another daily LeetCode problem, and the problem's name is fraction addition and subtraction. Okay, and the problem statement goes like this: you will be given an expression in the form of mathematical expression, basically in the form of string, and the expression will be of fraction addition and subtraction. Okay, so you have to return the result in the string format. Okay, and the final result, it is mentioned that should be an irreducible fraction. Okay, and irreducible fraction is which cannot be reduced down to any further. For example, you can take this example 120 by 9 and you reduce down it to 4 by 3. Okay, I hope you all know what a irreducible function fraction is. And if your final result is an integer, then you can change its format by using 1 as your denominator. Okay, so for example, if the let's say the result was 2, which is an integer, not a fraction, so you converted it into a fraction by using 1 as your denominator. Okay, so this is what you have to do. And before thinking of an approach, it is advisable to have a look at the constraints, because only then you will be able to see which approach will fit your constraints that is given to you. Okay, so according to the constraints, the input string only contains characters from 0 to 9, and these three characters, either a slash and plus sign or minus sign. Okay, these are the only characters that will be in your string. Okay, and so does the output. Okay, output will also have only these characters. Okay, so each fraction, input and output, has a format of, so each fraction that will be given to you in the string. Okay, so the whole expression is given to you. Each fraction is in the format of, firstly there will be either a positive sign or a negative sign, depending upon whatever is the sign of that fraction. Then there will be numerator, then there will be this slash symbol, and then denominator. Okay, so for example, this is also this format. Okay, but the thing here is to be noted is the first fraction or of the output, or the output or the first fraction, if it is positive, then you can this positive sign will be omitted. For example, here this fraction was positive and it was the first one, so that's why we omitted the plus sign. Okay, so I hope you are able to understand till here. Then it further states that the input only consists of valid irreducible fractions. Okay, so valid irreducible fractions will only be there in the input, and the numerator and the denominator of each fraction will always be in the range 1 to 10. Okay, so it cannot be a case like denominator is 0, okay, or a numerator is 0. That kind of thing will not happen. It is mentioned that the numerator and denominator of each fraction will be ranging from 1 to 10, both inclusive. Okay, if the denominator is 1, it means the fraction is actually an integer. Okay, and in a fractional format defined above. Okay, so then the number of, so this format will not be there, so this thing will not be there for integers. Denominator part will not be there. The number of given fractions will be ranging from 1 to 10. Okay, so given okay, and the number of denominator or the of the final result are guaranteed to be valid in 32-bit integers. Okay, so your result will always be able to be fitted in 32-bit integer. Okay, so let's see how we can solve this particular problem. So what we will be doing here is, let me clear this all out, and we will be starting fresh. So you need to somehow extract all the fractions. Okay, so your aim should be that from the expression. Okay, and store them somewhere. So extract out all the fractions and store them somewhere. Okay, and in which format you might be wanting to have those fractions? The format that is mentioned in the constraints. Okay, so this is the format that you will be wanting to have your fractions in. Okay, this format, numerator by denominator and their sign. Okay, so once you extracted all the fractions and in you are having them in this format, then it's just simple mathematical operations you have to apply. Firstly, it will be LCM of the denominators. Okay, then what you will be doing is, uh, for each numerator of the particular fraction, you will be multiplying that numerator, okay, into uh, sign of, whether it was sign of the fraction, okay, it was a positive or negative, so into sign, and this whole thing will be multiplied by LCM also. Okay, LCM, and the LCM will be divided by denominator. Okay, so this is what you have to do, and it will be done for the every numerator present in the fractions that you are having. Okay, and it will be on the top. Okay, and all of these things will be added to, let's say, a total number. Okay, so it will be now total divided by LCM. Okay, so then once you have done this, then you will reduce this. Okay, reduce this further. So how you will reduce this? What you will be doing here is, you will be finding GCD of these two. Okay, greatest common divisor. Okay, and let's say GCD comes out to be 10 or x equal. Okay, so you will divide this total by x and also LCM by x. Then it will be converted into a irreducible fraction. Okay, so this is the whole logic. Firstly, extracting all the fractions out. Okay, then finding then it's basic elementary mathematics. So you have to just find out the LCM of the denominator. Once you have find out that LCM for each numerator in the fractions that you are having, these fractions, you will be multiplying it with the sign that the numerator, the fraction was having, and the LCM that you find out of the denominators, okay, divided by the current denominator of the fraction. Okay, so this is essentially the fraction itself. Okay, this part. Okay, so this is what you will be doing, and then you will be simply adding these things into a variable total, and then you will be dividing this total by the LCM. Okay, so in a way you can say that you will be having the actual fraction, and then you will reduce this fraction by finding the GCD. Okay, and then this will be your result. Okay, convert this into string and return it as a result. Okay, and there will be many edge cases that you need to take care of. Now this was the mathematical part of it, or logical part of it. Okay, the calculation side. Now you might be asking that how we will be storing these fractions. Okay, so the next question should be how to store the fractions. Okay, so for that what we will be doing here is we will be having a mapping, and what will be that mapping? That mapping will be denominator mapped to list of two size integer array. Okay, and this two size integer array will be consisting of the first entry in it will be the numerator. Okay, so thing here is denominator can be common in some fractions. For example, 1 by 3 and 4 by 3, both of them are having same denominators. Okay, these two are same, so that's why I am taking list. Okay, so and this will be number and the sign of the fraction. Okay, not number, numerator, to be specific. Okay, so this is numerator. Okay, so denominator to numerator mapping will be there along with the sign of that fraction. Okay, so you will store them like that. Okay, and now the problems again boils down to how you will be separating these things. Okay, so for that what we will be doing here is, see, for the very first term you will not be given, first fraction you will not be given any positive or negative sign. Positive sign if it's a positive sign for that fraction. For example, as we have seen in this particular case, 1 by 3 was positive, so no positive sign was there for the first fraction. Okay, so you need to take care of that case. Otherwise, whenever you see characters, for example, I see a character here, it is 1. Right from where you see your first character to the point where you encounter either a positive or a negative sign, you will keep form, collecting the characters. Okay, and while you are doing this collection, okay, let me take this to the board so that we will be able to understand it more clearly. Okay, now it should be copied. Yeah, so what we will be doing here is, see, as I mentioned, for the first one, if it is positive fraction, then you will not be given any sign here. So as when you see the very first digit, you will keep continuing your operation till the point you see a positive or negative sign. Okay, positive, negative or positive sign will be there, and you will stop there. Okay, before that you will know we have formed a fraction. Okay, and in this fraction itself, in order to separate the denominator and the numerator part, you will have one indication. What will be that indication? That indication will be that your slash symbol will be indicating, okay, after this point denominator have been started, you should be stopping collecting the numerator. Okay, before that you will be collecting the numerator. So you will be having couple of variables. The first variable will be the numerator. Okay, numerator will be initialized to 0. Similarly, you will be having another variable denominator. Okay, and it will also be initialized to 0. So whenever you see the first whenever you see the character and the slash symbol is not encountered, so you will be having one boolean variable. Okay, slash found. Okay, so slash found will be initially set to false, saying that you have not seen slash till now, so you should be considering this part in your numerator. So you, what you will form, how you will form this numerator, you will multiply the current value of numerator by 10. Okay, so initially it was 0, so 0 into 10, 0 itself. Then you will add the current character. Okay, and you need to convert this character into an integer. So what you will be doing here is you will be taking its relative difference with 0. So this trick will give you the integer value. Okay, so your numerator now become 1. Had it been 13 or something, then again 1 into 10 plus 3. Okay, this logic will be applied. You would have got your numerator 13. Okay, so I hope you are able to understand my point here. So this is how we will be separating the numerator and denominators and keeping different fractions separate. Okay, just by seeing that, okay, we have seen a sign here, stop here, and whatever is fraction is formed till now, insert it into our mapping. And what was that mapping? Mapping was denominators mapped with the list of numerators and their fraction signs. Okay, so once you are having this mapping, then you will be applying this operation. Okay, firstly finding the LCM of the denominators. Once you are having the LCM of the denominators, then numerator into sign into LCM whole divided by the denominator. Okay, and you can be sure that this will be an integer because LCM will be divided by denominator. Okay, so you need not to worry about that, and don't forget to use this sign of the fraction. Okay, and it the whole thing for all the fractions available will be stored in the total, and then you will be reducing this by finding the GCD and dividing GCD by total and LCM. Okay, and then converting it to the string. So now without further delay, let's quickly see the implementation of it. Okay, so the whole logic and everything will be same in the implementation also, but if you are still not very much clear about the approach, it will be more clear into the implementation part. So let's bring the code to the board. Okay, so this is the code. Just a second. So let's copy this code. Okay, I know it's a little bit lengthier, but we will be able to understand all of it. So let's remove this toolbar for clarity. Okay, and I will be explaining you step by step what we are doing. So firstly, as I told you, we need to store our fractions somewhere. Okay, so this thing will be used to store fractions. Okay, and this is the mapping that we were talking about. Okay, denominator to sign numerator mapping. Okay, this mapping, this one. Okay, so denominator to a list of numerator and sign. Okay, so this is what essentially we have declared here. Okay, and then this is just a variable to see what is the length of the current expression or fraction addition or subtraction expression that is given to you, to be specific. And then you have converted this string or fraction into a array of characters. Okay, just for the sake of easy access. Okay, so because in Java it is you have to use to caret function. Okay, so in order to get easy access, I have converted it into a array of characters. Okay, this expression. Then you will initialize one index. So this index will be nothing but, let's say this is the expression that is given to you. Okay, so you will be forming the fractions by traversing this expression from left to right direction, and this index will be a kind of pointer that will be pointing to the current character that is being processed. Okay, so this is that, and then this will be your sign. Sign will be the sign of the current fraction that you are forming. Okay, and then you will do a linear traversal of the expression character by character. This while loop is for that. Okay, and then you will see what is the current character being processed. Okay, so this part is for string processing or expression processing. And what is this for? This is for to extract out the fractions and store them into map. Okay, extract fractions, you can say. Okay, and they will be going into the map. So if it is a negative sign, then you will see that sign's value is changed to -1, indicating that we are having a negative fraction. Okay, and you will simply increment your index, saying that okay, we have processed this sign and now we should be moving forward. And if it is a positive sign, then similar thing will be done, but sign will be this time positive, indicated by 1, and you will be moving one index uh, again further. Okay, so you might be asking how this situation will be encountered when you are not having this, positive sign on the very first fraction. So for that case, you are only doing increment of the index whenever you are seeing sign. Okay, if there is no sign, no increment. Okay, so then you will be starting to form your denominator and numerator. Okay, so this part you will be forming your fraction. Okay, and this slash found is the variable I was talking about. Will be telling you where whenever your slash is encountered, from that point forward you will be forming your denominator, and before that point you will be forming your denominator. Okay, so then, as I told you, you need to form a fraction going from left to right direction till you see a sign. Okay, either you see a positive sign or negative sign, you will, till then you will keep continuing and forming your current fraction. Okay, so whenever you see a forward slash, uh, I think this is a forward slash, or you can call it slash. So whenever you see a slash, you will know that denominator forming part have been started, and you will be doing that. Otherwise, if slash is not found, you will be forming the denominator, and we already discussed how we will be forming, multiplying by 10 and taking the relative difference with 0 character. Okay, that will give you the value of actual integer value. Okay, similarly, if slash is being found, then you will be forming your denominator, and since we are doing the processing character by character, so this index will be increased. Okay, and if the current value of your denominator is 0, indicating that you are not having any uh, you know fraction, so you are having only an integer. Okay, so it's indicating that your integer was there. So for integer, as the problem statement mentioned, you should be using 1 as your denominator, so that's why setting the value of the denominator to 1. Okay, now you are adding your fraction, whatever the fraction you formed, into your map of denominator to signed denominator. Okay, and if you are seeing this denominator for the very first time, then you will be initializing a list for that, saying that okay, we are seeing it for the first time, we are not having corresponding list to it, so that's why let's just get a new list and start adding numerators with their signs. Okay, numerator and their signs. Okay, I hope it's clear till now. Then comes the mathematical part, finding the LCM of the denominators. Okay, LCM of denominators. Then uh, using that formula, a number sign into number into LCM, okay, divided by the denominator. Okay, to get the total. So situation will be like this. Just a second. So there was some glitch in the software, and I had to copy the code again. Anyways, we were discussing that how we will be forming the fraction that we have to return. So as we talked, we need to have this total by the denominators, and total will be the sum of these things. Okay, so this is what we are doing here, is having the total. Okay, total number, and it will be the sum of these, numerator into numerator sign into numerator into LCM, all divided by denominator. Okay, And then once you are having this, you will be having something like this: total number divided by LCM of denominators. Okay, so then you will be further reducing it. Okay, you have to reduce it to irreducible fraction. For that, you should be finding the GCD of the total number and the LCM. Okay, and then you will be simply dividing it, and then you will just return the fraction in the format that was required from our side. Okay, it is that simple. And if you talk about how we will be calculating LCM and GCD, so see, for LCM will tell you one property: LCM of two numbers A and B into GCD of two numbers A and B is equal to the product of those numbers. Okay, so this property is being used here. So this GCD will be coming to divide A and B. Okay, and you will get your LCM. So the only thing that you have to do is to find the GCD. Okay, so here we have applied Euclidean algorithm. Okay, pardon me if spelling is incorrect. Okay, so you in this algorithm, what you do is I will be providing link for this algorithm's explanation. Okay, so link will be there in the description box. You should definitely check it out if you are not familiar with it. So it is based upon the fact that if there are two numbers A and B, and A is larger than B, so if you replace A with the difference of A and B and take the GCD, okay, it will be same if you take the GCD of A and B. Okay, okay, if GCD, so this is just the difference of these two. So if you uh, reduce the larger number by to the difference of the larger and smaller number and take the GCD remains the same. Okay, so this is the property that is being used. Okay, so here once this algorithm returns you the GCD, then it will be able to be used in your calculations. Okay, and this will be the whole approach. Code will be provided in the GitHub repository link. Okay, you can check it out there, and C++ and Java implementations will be there. And if we talk about complexity, time complexity wise, it's order of n. Okay, and we are not taking into account uh, the GCD and LCM calculations because of the range here is very small. Okay, as mentioned in the constraints, the range was 1 to 10 only. Okay, so that's why order of n time complexity almost linear. Okay, and space complexity wise, number of fractions that you will be having will be stored in this map. Okay, so order of number of fractions. Other than that, we are not using any extra space here. Okay, so these are the complexities and this is the approach. I hope you are able to understand. If you are still having any kind of doubts or any queries in general, then please feel free to ask them in the comment section. And I really hope this solution walkthrough added some value to your journey of honing your DSA skills, and keep solving more and more problems. And I will be seeing you in the next video. Thank you for watching.